So my name is Andy Krudge. I'm a product manager on the Amazon Elastic File System team. And I'm joined here by Edward Chitnitsky, who is a product infrastructure manager at Thomson Reuters. So today in this session, we're going to be talking a little bit about how Thomson Reuters uses Amazon EFS today in their content management and web serving infrastructure to deliver billions of pieces of content to hundreds of millions of visitors each year. So to give you a high-level sense of our agenda for today, first I'm going to talk a little bit about Amazon storage, and specifically I'm going to give you an overview of Amazon EFS. Afterwards, I'm going to hand over the mic to Edward, and he's going to talk about Thomson Reuters and their journey towards using Amazon EFS. Afterwards, we'll share some references with you, share some information that we have on other reInvent sessions this week, and then finally we'll end with a Q&A. So first, we want to talk about just choosing a storage solution. So we wanted to think, okay, what do you think about when you're choosing a solution for your applications today? And really, some of the criteria that we want to think about are, first, the storage type. Which storage type makes sense for your application? Different storage types offer different interfaces, different semantics, different permissions models that may suit your applications better in some senses. We also want to talk a little bit about your features and performance characteristics of different storage offerings and how those may relate to your applications. And then also we want to talk about the economics, the total cost of ownership of what a solution may look like on various storage offerings. So going into the storage type, there are three types of storage that we have today at AWS, as well as just for storage in general. These three types are file storage, block storage, and object storage. So for file storage, data is typically stored as files, and this data is stored in a directory hierarchy. So each file has particular metadata that's associated with it, and your data is really stored natively in a file system format. So if we're talking about this in the enterprise context, this typically means that your data is shared over a network, and your file data can be accessed from multiple clients at the same time. The analog to on-premises is something like a network-attached storage, or a NAS. So the second type of storage that we have is block storage. And in block storage, your data is stored as a block on a disk or a set of disks. And these disks are typically attached just to a single computer. So many operating systems can format a disk to present a file system layer on top of it, but the block device itself is really just storing continuous blocks of data. And so this is typically referred to as locally attached storage or locally attached disks. And finally, we have object storage. So with object storage, your data is stored in a container called an object, and each object is identified by a key in a flat space. So unlike file systems where your data is stored in a hierarchy, with object storage, everything is stored in a flat namespace. And to access data in an object store, there's a simple API that you can use to get data or put data. And this API is typically accessed over the internet. So this is a session mostly on Amazon EFS, so we want to talk a little bit about file storage. First, we want to start off with, why is file storage so popular? Well, one reason is it works natively with operating systems today. Most operating systems are built around file storage, and they expect file storage semantics just to operate. And in addition, operating systems provide users and developers with APIs to actually interface in a file storage way. In addition, file storage offers shared access across multiple clients or multiple threads, and it does this while providing consistency guarantees and locking functionality. So what this allows developers to do, what you can do is run a multi-threaded or run a multi-node application and ensure that your data is consistently stored and that you have a consistent way of accessing it without interfering. And then finally, file storage provides a hierarchical namespace. And this is a pretty common namespace. It's an intuitive namespace, and it's something that many users are just familiar with. So taking a look at performance, since that's another aspect to consider when choosing a file storage type. So up here I have a graph showing latency on the x-axis and throughput on the y-axis, comparing the three storage types that we talked about. So on the bottom left, we have block storage. Block storage provides the lowest latencies of these three storage types, but it doesn't scale to the same levels of throughput that you may get with file storage or object storage. Again, block storage is a single attached to a single EC2 instance or single client, and it's because of its low latencies, it's really ideal for applications like boot volumes. It's also ideal for applications that are running single node databases on a single instance. File storage, it's generally designed to provide still low and consistent latencies, but it's also designed to scale to tens of gigabytes of throughput, gigabytes per second of throughput. So allowing a much more scale out performance from a throughput, from an IOPS perspective. And then finally, object storage provides the highest level of throughput scalability. And it really allows you to take advantage of many, many nodes and really scale your workloads, but it's not necessarily designed for some of the most latency sensitive of applications. So before EFS, and for context, we launched Amazon EFS about a year and a half ago. So if you wanted to implement shared file storage yourself, this is what a typical setup on AWS would look like. So this setup would involve a file server, such as an EC2 instance running an NFS server. And this file server would have locally attached volumes, we're assuming EBS volumes, to actually store your data. And if you wanted a highly available, highly durable setup, you may want to replicate this data across multiple availability zones, either synchronously or asynchronously. So you'd have your clients who are connecting through your file server to access your data, but all of the infrastructure for your file storage itself would be multiple file servers, multiple storage volumes, and all of the networking associated and connecting those boxes as well. So you'd be responsible to operate all of these pieces of infrastructure, to maintain them, to replicate the data, and for managing failover in case there is a failure that happens. So with EFS, our goal is really to provide a fully managed file service that takes a lot of these complexities out of the hands of the users and provides a simple experience. So with EFS, some of the core design tenets that we were considering when we were developing the product were for it to be simple, elastic, scalable, and to be built on a foundation that's highly available and durable. So going into each of these in turn, so simple. What makes EFS so simple? Well, first, it's fully managed. The do-it-yourself solution that I presented on the previous slide, all the file servers, the EBS volumes, the networking, all of that infrastructure is fully managed by EFS for you. So you don't need to provision hardware. You don't need to set up any software to access your file system. It's just there. And you can create a scalable file system in a matter of seconds. And also, EFS is simple pricing, which we'll go into in a little bit later. EFS is also elastic, as the E in EFS implies. So file systems on EFS can grow or shrink elastically as you add or remove files. So you don't need to provision a volume, you don't need to provision disks to hold your data. The file systems just grow as you add data, and the file systems shrink as you remove data. And you only pay for the storage space that you use. So if you add a lot of data and then delete it at a later date, you're only paying for the amount of data you ever have in your file system at any given point in time. EFS is also scalable. So file systems can grow to petabytes of scale, petabytes of capacity. And along with that storage capacity, your file system's throughput and performance also scales as your file system grows. And regardless of your file system size, EFS provides consistent, low latency, regardless of the size of the file system or how much data you have in it. And in addition to just storage and performance scalability, EFS also allows you to scale out your applications horizontally, having many, many concurrent, thousands of concurrent NFS connections across multiple clients who are accessing the same data concurrently. And finally, EFS is designed to be highly available and highly durable. So each file system object that's stored on EFS is redundantly stored across multiple availability zones within a particular region. What this means is that in the unlikely event of an AZ being unavailable, you are able to continue accessing your data from other availability zones within that region. And so this is superior to traditional NAS solutions that may exist on premises today, largely because many of these reside in a single data center and are therefore susceptible to some sort of networking issue that may take out all of the resources. And for this reason, EFS is appropriate for production and tier 0 applications. So EFS, we really designed it to serve a wide spectrum of needs. From one end of the spectrum, we have scale-out jobs that require high levels of throughput, highly concurrent access from many, many clients. And on the other end of the spectrum, we also have customers who are running metadata-intensive jobs that are sensitive to latencies and have lots of serial I/O. So one of the great things about being designed for a wide spectrum of needs is that we find that we have a wide spectrum of use cases that our customers use EFS for. Between database backups and home directories, big data analytics, which drive high levels of throughput, IOPS through their file systems. And then we also have web serving and content management, which we'll go into a bit later with Thomson Reuters use case. So going into security really briefly. So EFS offers you several features to improve the security and to control access to your file systems. One of the features that we have is we support security groups and network access control lists so that you can determine which EC2 instances or which clients are able to access your file system. In addition, we support POSIX permissions within the file system, user group permissions, read, write, execute access, things like that. We also support you can control administrative access to your file system using Amazon IAM policies. And then just in August, we launched encryption of data at rest on EFS. And what this allows you to do is to encrypt your data when it's stored on disk using keys managed in AWS KMS, further increasing the security of the data that you have stored. So EFS can be accessed from a variety of different environments. So you can access EFS from EC2 instances in your VPCs. In addition, you can also access EFS over Direct Connect from your corporate data centers, providing scale-out storage, even as accessible from on-premises. And then just this week, we announced that you can now access EFS from software-defined data centers running within VMware Cloud on AWS. So we've added a new place where you can continue to access your same shared file storage on EFS. So going into economics a little bit. So with EFS, there are no minimum commitments. There are no upfront fees. You really only pay for the amount of storage you use. And so you don't need to provision an amount of storage and worry about that at all. It's simply we charge you, in our US regions, 30 cents per gigabyte month for the amount of storage that you have in your file system. So to put this number in context, so going back to the do-it-yourself solution that we talked about a few minutes ago, if you were to build a shared file storage on AWS today, and it would look something like this. So the costs associated with this solution, the pure dollar costs, are the EC2 instance costs for the file servers, the EBS volume costs for all of your storage, and then also the cross-AZ data transfer costs, since you would be synchronously or asynchronously replicating your data across multiple availability zones. So in this example, let's say you wanted to store 500 gigabytes of data. On EFS, your cost is as simple as 500 gigabytes of data, 30 cents per gigabyte month in our US regions. Your total cost for that storage would be $150 per month. In the do-it-yourself solution on the previous slide, let's say because nobody runs their disks at 100% capacity, just to allow for increasing storage, let's say you would need to provision, in a provision model, 600 gigabytes of storage, which would need to be replicated across availability zones, and adding in the compute costs to serve your data and the inter-AZ costs, this total solution comes out to $540 a month. So for this one particular use case, taking a look at the total cost of ownership, EFS we found to be 70% cheaper than a solution that has you doing it yourself. So in terms of regional availability, EFS is available in 6 regions today. We are available in 3 regions in the US, 2 regions in Europe, and we're also available in Sydney, Australia. And we have more regions coming soon. So with EFS, we've completed, as I mentioned in the beginning of the presentation, there's 3 types of storage out there: file, block, and object. So with EFS, we're able to provide you with a common set of building blocks for building your applications. We have block storage in the form of EBS. We have object storage in terms of S3 and Glacier. And now we have file storage that's provided by Amazon EFS. In addition, we have a suite of data security and management services within AWS to help you really secure and manage the data that you have in your stored services. And we also have a variety of data movement tools that help you move data either between AWS services or from on-premises into AWS. On the note of data movement tools, actually just last week we launched Amazon EFS File Sync. So what File Sync does is it allows you to sync data from existing file systems into Amazon EFS file systems. Again, this is something we launched just last week. We're very excited about it. And so EFS File Sync is a simple and a fast solution to get your data into Amazon EFS. It's up to 5 times faster than standard Linux copy tools, and it's also secure. We encrypt your data in transit while it's moving into your EFS file system. So this can be used to move data either from on-premises into EFS, from a do-it-yourself solution like the one presented into EFS, or you can even use this to move data between EFS file systems in 2 different AWS regions. So with that, I'd like to hand the microphone over to Edward from Thomson Reuters to talk a little bit about his journey to using Amazon EFS.
Thank you. Hello, everybody. My name is Edward Zanitsky, and I'm Production Infrastructure Manager for Reuters.com. For you guys who are not familiar with the Reuters, we are a worldwide news agency that provides our customers with a lot of different informations, with videos, pictures, news content, obviously, financial information, charts, all sorts of search details, if you will, and advertisement, and much more information, much more additional other information. At any given time, or actually you see the stats right now, we actually serving monthly close to 222 million page views and over 48.5 million unique visitors. We are supporting 17 multilingual desktops and 4 mobile editions. I'd like to actually take you on a journey with me and tell you how actually our migration worked out through the whole, I guess, cycle from old existing infrastructure to AWS. So for that matter, let's start on our old infrastructure. Let's take a look. So as you can see, fairly complex. We have 2 live data centers, classic 3-tier architecture with over 120 systems on each side. We leverage 3 pairs of the GTMs for optimized DNS resolution and a proper load balancing between data centers. Redundant sets of actually external and interlayer firewalls for security, internal and external security. We employed a pair of the load balancers that actually had internal and external IPs for a load balance inside and have a better communication between GTMs and load balancer to actually allow load balancer know about status of the pool members. So at that point, the logical decision will be made and the traffic will be diverted automatically to the healthy data center. We used third-party edge caching. We had a couple different master replica database set up. For example, we have NewsDB, we have CMSDB, and we have multiple market data DBs. And all those databases actually were replicating cross-Atlantic to a data center. So it was provisioned for us special circuit, so obviously we had to pay for it. We also use NAS for our static content. We use custom CMS. And all this actually has to be aligned and figured and requires over-provisioning, because at any given time we have to be ready for supporting any traffic spikes, any breaking news, and so forth. So at some point we start looking, so it's almost 2 years ago we start looking, and we seen a potential issue coming. So our servers were quite old, and they were coming to the end of supportability life of supportability. So basically, we had to do something. So we cannot deploy newer operating system on it because the systems would not support that. So we pretty much locked out of that. And our co-location data center actually were fixed on the capacity. So we seen a potential problem coming because our environment actually grows, and we had to actually make a lot of different changes, which actually would not, our old infrastructure would not support. So in any of those actually potential issues, we were limited with the bandwidth, and we had a constraint. We have a limitation in performance and obviously supportability. So, and obviously we had to, as I mentioned before, we had to over-provision. So obviously the huge upfront cost was involved. So we start looking. And we try to actually locate or potentially discover what our options are. And at that point, we looked at a couple different possibilities for us. So the first possible option for us was existing third-party provider, which actually offer us at potentially higher cost design that actually was based on a particular footprint that actually we had for quite some time at that point. The issue, one of the concerns that we had, that they offer unproven tool to us. So we actually we would go to inside of their data center again on their virtual environment. So were any basis for us to really understand or see any data points. And of course, again, we were locked in certain sizes, so we wouldn't be able to grow at time when we need it. So it wouldn't be any capacity and demand, and it would be, huge upfront cost again. So we pretty much at a square one. So the second option was, internal data center. So internal data center for us was a possibility, but basically what we were looking in our journey, we were prefer to have the environment or location that will actually be geo-positioned properly for closer to our customers, and it wasn't really optimal for our environment. We also had a limitation, or actually we had to share our resources with different lines of business. And that actually was a potential concern for us. We had difficulty quantifying the true cost of the environment at that point. And one of the, biggest issues for us was it was the lead time involved for extra capacity for our infrastructure. And the third option was Amazon. So at that point, we were quite scared because it was a huge learning curve for us. And we really, we're not sure how it's going to play out, but we still look into it. So potentially it was a couple different options with the application migration. One of those were drop and go, which really wouldn't give us any benefits. Or the other option was port our application to the Amazon for native support of their technology and for our potential growth and flexibility. From the further investigation, it definitely was most cost-effective option. It was true capacity on demand, so basically you can use, or you paid for what you use at any given time. And one of the biggest, I guess, parts for us, it was we actually had a full system control. So at that point, we can adjust and configure whatever necessary for us and for our application, so to our application running optimal and serving our customers with the proper content. And it definitely was a clarity in the cost. At any given time, you can go and look how much you spend and how much you actually will spend in the next week or month or whatever. So with that current cost rate, running rate. So when we weighted all those options, we finally made a decision. We're going with AWS. It was quite exciting, and a lot of folks, like I said, we were, unsure, but we jump in and we try to figure it out, what's going on and how it's going to work out. So when we made a decision, we tried to draw the environment, try to build and see how it's going to work out for the team and for our line of business. And as you can see right now on the diagram, this is our network design. So basically, somewhat simple, maybe somewhat, you can see the many lines there, but quite frankly, it's a lot of moving parts out there. Some of those actually not there because it would be really busy, it would be really hard to understand. But anyway, on the long run, we have a request coming from a front end, getting passed through the set of Nginx load balancers and passed through, based on the header, passed through to the internal ELBs, based on their requests going to the type of the edition, to the US or Japan or China or whichever edition you want, or maybe there is a request for market data or search capability and so forth. So let's see which actually technology involved with our implementation here. Route 53. So we use a Route 53 for our DNS resolution with built-in health monitoring to ensure our traffic serves only from a data center that actually reports healthy status. Any other status actually force the traffic to be diverted to the healthy data center. Our custom Route 53 scripts actually allow us to impose weighted routing policies for DNS resolution and actually helping us with the failover. This gives us ability to control our DNS resolutions for over 60 different domains. And all this actually done by execution of the one simple script. CloudFront, our new edge caching technology, which actually helped us with bring our content to the customer in very fast and efficient manner. CloudFront actually supports SSL, as you know, and till fairly recent, we served the traffic in both HTTP and HTTPS. But in the last month, we actually move all our content to HTTPS, and quite frankly, it's a matter of like one simple click per edition, and we're all ready, and we're serving HTTPS. Certificate Manager, simple, interesting tool. I'm sure many of you guys know that certificates, SSL certificates can become a headache, quite frankly. And sometimes with our busy schedule, something you missed, you overlooked the email that reminds you, oh, don't forget to upgrade or update your certificate. And sure enough, at the point or the same day or a day after, you're realizing, oh my God, I'm getting an error, people are complaining. What are we doing? Simple solution, guys. So we port all our certificates to Certificate Manager, and at this point, they're available to CloudFront, so you can pull them quite easily and activate them right there. You can populate to the ELBs. And it works quite well, and it's free. So, and also they actually watching to make sure the certificates are not expiring. So it's win-win situation, guys. Security groups. It's a potential, almost like interlayer firewall that controls your layer, separates your layer, like say, for example, web apps from a databases. So you definitely don't want a customer be able to hit directly databases, or quite frankly, if you limit your access from a databases out to the internet, so you configure and control your security groups at that point. Web application firewall. Web application firewall, we actually coupled with advanced shield technology. And actually, it monitors and protects our environments, and actually controls, and we can put the filters for unwanted bots, actually, that actually, quite frankly, hitting our environments, and they're quite annoying. So we can configure and protect ourselves from SQL injections or from cross-site scripting. One of the main things that Advanced Shield provides is DDoS protection, and actually it's a big team behind watching and monitoring, and sometimes they actually send us a note, guys, you might want to watch this, and or they start communicating to us. It's really, really useful. And we also protect our external DNS. We all remember that fairly recent attack on DNS where, definitely this protection would help and save us. Dynamic, the configuration for actually web application firewall is quite simple and fairly dynamic. So you don't have to go far. You just couple clicks there and there. You can set up and filters that you want. You can block one at IP and so forth. I'm sorry. VPC, I'm sorry, I didn't see it. So VPC, it's a must for any environments, just as my recommendation, guys. So basically, you can think of you creating your virtual data center. So you blocking everybody out, you creating your data center, you can apply your specific IP spaces, addresses, whatever you want to do there inside, and you configure properly configure your gateways, and at that point, you sort of seclude it, you separate it, and as long as everything done properly, you don't have to worry about anybody can get in and out, and you can configure your access points from inside and out, and you do whatever is necessary there. S3, storage. So we're using quite extensively. We're using for our application deployments. So we push in our images there, and then when we launch the script, it's referenced and pull in the images right to the system, so it's very flexible. We're using for cloud front files, log files, and it's very simple. It's simple, accessible, so basically if you have a concern, something, you can pull the file, you can throw it in the system, and you can look through the files and see what's going on. And we also, some of our smaller sites, we actually push in the content right to the S3, and we can serve the site right from S3. It's very simple, a nice solution. One of the beauty of it, it's actually cross-region replicated. So basically, if we have 2 or 3 regions or whichever we want, we actually, like for example, in our scenario, we have 2 regions, we can activate multi-regional replication. The content will be pretty much available instantaneously in the other region. Simple queue services provides our simple, helps us with a simple messaging between the systems and our environments. Elastic file system, I would like to sort of not go into much in details right now because I have a few additional slides on it. I would like to go in depth just a little bit later in a minute. CloudFormation. I'm sure many of you guys heard stories and complaints where deployment happened. Oh my God, we have a problem. How come we didn't see the error or we didn't see a problem in QA? It must be a problem with our QA environments. It's not configured the same way. Well, when you using the CloudFormation, this definitely can actually eliminate that complaint right away because on our experience, if you configured CloudFormation properly, you can build your dev, QA environments, your pre-prod staging, whichever you have, and to match in production. So that complaint pretty much baseless at that point. So CloudFormation, great tool. CloudWatch, simple metrics. Normally, guys, as you know, we monitor system status, disk usage, disk capacity, memory capacity, CPU utilization, network in and out, so forth. So heavily in use in our environment too, and actually triggers some of our actions, which I'm going to mention in a second. Elasticsearch, we successfully migrated from third-party search appliances, and we create a cluster. It works quite well. It's indexed in our database, and it works very well if one of the systems going down, or so index get distributed back and forth. So it works very well and helping our customers to serve the search requests almost instantaneously. Elastic load balancers, you see they actually popped up over there. We have a lot of them. Like I said, unfortunately, I wouldn't be able to fit them all there. I think we use in between like 60 or maybe 70 load balancers, internal load balancers in our environment. The load balancers are quite important for us because what they actually do, they pass in the HTTP request to the appropriate port internally, the port that actually application listens on. Also, it monitors the status of the application. So basically, if the health monitor would tell, okay, I'm okay, 200, no problem, here's your request. But if the application actually folds and reports the error, at that point, the system is out of rotation and the customer not getting actually page unavailable or 502 or 500, whatever. So it's a really useful thing. Auto scaling, one of the things that really, it's a beauty of the environment. So basically, based on the CloudWatch, certain parameters we're set up when we're triggering auto scaling. And at that point, auto scaling actually based on the demand. At our point, for example, it's a CPU load, but you can configure a couple different or many different options. And we're using a simple policy. You can be more complicated, create a more complicated policy. But at that point, what basically happens, we launch systems in pair as a redundant, as multiple availability zones with one region. So this way, in any failure or potential failure of one availability zone, we still will be running and active. And basically, when the load goes down, autoscale actually take the system down. So we have true capacity on demand. CloudTrail. Well, really nice tool. Hopefully you don't have to use it too often, but sometimes you need to see who accessed the systems, who did something in the console too, and what's going on. And if you want to go with some fine forensics, that's the tool for you. RDS, Relational Database Services, provides a simple and scalable database solution for us. Actually supports cross-region replication. It does automatic backups and actually patchable automatically by the AWS team. So you don't have to pretty much do anything with it. So it's quite nice. And we're also using OpenSwan. It's been recommended by our Amazon team for our proprietary database replication. So it's basically we created VPN tunnel between our data centers, and we can replicate, we can rsync our static content, we can sync our databases. It works quite well. and it's actually redundant. Failover happens in instance, and we actually tested many times. It works very, very well. All right, now guys, I would like to go back and talk about our EFS migration. So in traditional environments, specifically to ours, the network attached storage is quite important. So we are using for static content, for pictures, as you're probably well aware, we actually have a very extensive amount of high quality pictures. We're storing our CSS files and JS files, and we have to maintain this, those files actually in a couple different locations for accessibility and for faster support, faster access by the customers. So when we start our journey, we start looking what's actually a compatible option for us in AWS. So we start looking at S3 file system, and at that point, S3 file system worked okay, but what we realized that S3 would not support file attributes. So it would basically, for us, is important timestamp when the file was created. So basically, we can reference and we can index as necessary. And S3 would not support that. So what happened? We start panicking and we start calling our guys, our AWS support team. So Fabi and Sam told us, guys, don't worry about it, we got you covered. So how about looking at EFS? And exactly like Andrew said, the EFS at that point when we started was quite fresh and like fresh off the press. Not much, I mean, information not many people use yet. So we try to learn and discover what's going on, how this stuff's going to work out for us. So, and guess what? Right away we realized great performance and data consistency, built-in redundancy. So we don't have any issues, you know, that we're not going to miss any or lose any files. Metadata protection, as the file attributes will be protected. Most important part for us. No capacity limitation. I'm sure many of you guys been through the exercise when you're running on the discrete boxes, you're running out of space on NAS, try to increase the size of a NAS. From SA perspective, DevOps perspective, guys, I can tell you, I'm sure probably you've been through it. Backpack, a couple boxes of pizza, and overnight on Saturday and Sunday is pretty much whole ordeal. Create a new file system, try to copy the data, then want to make sure that everything mounted properly on your systems. So you have to mount, like in our case, we have over 70 systems that actually mounted EFS. And after that, you have to do the cutover. So you want to make sure nothing writes to it. So it becomes a nightmare. So I'm sure you know all about it. So basically, here we are. This actually eliminates all these things. So no capacity limitation. So you pay as you go. You're using flexibly. You're increasing your capacity. You're decreasing your capacity. You're all there, so you don't have to worry about it. Very easily mounted, as I mentioned to you guys. A simple FS tab update for a limitation if you want to do read-only, or if you would like to do read-write. Welcome can be done that way too. And one of the biggest one, I guess, from our perspective, I just for interest, I looked through and I figured out we just shy of 20 terabytes between our development, multiple QA, pre-production, production environments, and through all this, we have a huge saving. We're saving over $10,000 a month by using EFS. On this graph, you can see it's just a snapshot from one of the dashboards where we're monitoring the capacity and I/O writes and so forth. So, but of course, there's the challenges. When we decided to move to EFS, we actually had a concern. How are we going to move? At that point, we had just shy of 5 terabytes of data. How are we going to move that data to EFS? So pushing that stuff over the internet will be just crazy. So of course, what we do, we're calling guys again. Say, guys, we panicking. What's going on? How can we do that? And of course, guys, like it's like rabbit out of, they pull the rabbit from the hat. No worries, we got you covered. How about you look at Snowball device? Here we are. So we did some reading, and sure enough, it was the solution for us. So basically, what we did, we activate the process, went online, couple buttons, and the device was on its way. Within 2-3 days, it arrived. We grabbed the box, delivered it to the data center, and at that point, we started panicking. Oh my God, where's cables? How are we going to do it? But here enough, we opened the back door compartment, and every single cable, whatever you possibly can use and think of, it's there. So we connect the device right to our infrastructure. It was configured within a matter of minutes. We start transferring the files, and we're like thinking, something not right. The rate that actually guys proclaiming can be actually, or it's supported by device is quite low. So we start talking to the guys, and again, and because we try to, I guess, copy directory by directory, and they said maybe, you know what, maybe it's not the best way for this particular device. Let's try to tar the directories, try to make a bigger files, obviously, when you're copying millions and millions of small files. So basically, it's what we did, and it worked out quite well. So we store all data on. Our data was protected because it came actually with the 256-bit encryption, so all the data was loaded on the box, it was encrypted. So we packed everything together, block, generate the label on the spot. It's like a magic. You push the button, touch screen, it generates the UPS button, goes out the door. A few days later, we got a notification that the drive is ready to, and connected to the network and ready to be actually used, and we can copy the data. But as Andrew mentioned, that at that point, we were not able to copy right from the Snowball device to the EFS. We had to do like a staging. We actually copy our file to S3 as a tarball, and then we moved it to EFS. And it worked out very well. All file attributes were saved. We were saved, so we were ready to migrate. We were actually ready to proceed with our migration. So bottom line, guys. By moving to AWS, we actually embracing new technologies. We forget about those days when we had to run to a data center and replace the drive or look for that broken drive or somebody pulled the cable or something. So no worries about there. We have a true capacity on demand where we can be very flexible. We don't have to run full capacity at night or based on the time zone. Different editions, different systems can be adjusted to the proper sizing and proper amount of the systems. No more NAS, volume expansion, as I mentioned to you before. We are constantly on the current hardware. Many of you guys who are already running on AWS probably know, but if you are new to it, you don't have to worry about it because all of a sudden you will see a small email in your box saying, you might want to look at the instance so-and-so, we are planning maintenance, or this particular instance actually running in degraded mode, so all you need to do, just go and just to the console and just reboot the system. And Magic 101, system actually moved to the new hardware and you all good. It runs quite well. We don't have a bandwidth capacity anymore, limitation. So that gone away because, with whatever, if we need more, they're more for us, as much as we want to use. With advanced shield technology and web application firewall, we actually have a better protection. We're protected from DDoS and DNS scaling protection. And the best of all, we were able to get better service for 67% less. So our saving is 67% compared to our existing environment, old environment. So no more over provisioning. It's a true capacity on demand. This is pretty much it, guys. Thank you very much for listening, for the opportunity. And I'm going to pass to Andrew.
All right, thank you, Edward. So real quick, before we finish up, I just wanted to share some references, some materials with you that may be helpful. So we have a whole suite of blogs, white papers, reference architectures, things like that, useful tools and documentation on our website, aws.amazon.com/EFS. So I'd encourage you to go check it out. We have some tutorials that are really helpful just to understand good use cases and good ways to use the product. Up here, I have a set of some of the reInvent sessions that we had this week that were focused on EFS. So this is actually the second to last session, or third to last session, sorry. There is a session at 5:30 if you're interested, talking about building scalable and highly available messaging services using IBM and TIBCO. However, all of these reInvent sessions will be posted to YouTube. Many of the previous ones already are on YouTube. So I would encourage you to check them out if you're interested. And lastly, we have a suite of storage training offerings, reInvent online at aws.training. And also, we have various opportunities for you to make progress through these trainings on some of your AWS certifications, if that's something that you are working on. All right, at this point, I want to thank all of you for attending this. We're going to open up the floor to questions. There's a microphone in the center if you want to step up there so that the whole room can hear. But otherwise, thank you.
Question.
Sure.
What's the largest EFS deployment so far, or order of magnitude, since you probably can't say specifics?
So yeah, as you mentioned, we typically don't share those kinds of numbers. I mean, EFS file systems can scale and have scaled to petabytes of scale in terms of total storage, if that helps.
So my question is about the metadata. It seems to me like POSIX attributes are really important for you, right? So S3, if I believe correctly, has dates, right? So I'm guessing some other attributes are really important for you, right? I'm asking this because S3 is, I think, 10 or 12 times cheaper than EFS. And for serving static data, I think it would be good enough. So what was it exactly that made you use EFS instead of S3 for static data?
Well, to go in, I guess, with some details from that point, basically, you pretty much hit the nail in the head. The timestamp of creating of the file is important. So basically, our database indexes and reference to it. So when an editorial curating a story, they reference in this particular file. We cannot rebuild the index while you understand it's going to be huge. We wouldn't be able. We were in quite crunched amount of time. So you are absolutely right. It's a potential. Maybe in the future we're going to look into it. And for the matter of fact, the smaller one, we already try to use the S3 as a S3 file, or actually S3 storage, which is very flexible and much cheaper. But in our case, we wouldn't have that option. We have a limited amount of time. We need a solution. And to migrate the data without really redo a lot of re-architecturing or remaking something in the back, it was actually a proper solution for us.
But if you were starting from scratch, you would use probably S3.
Well, very well possible. Very well possible. Again, it's based on the business requirements.
And this is something that we actually frequently see with EFX, because we support standard POSIX permissions, all these file system semantics and interface. A lot of users find that they can just migrate their existing applications from on-prem or whatever they have, move them onto EFS, and they work as is. So there are a lot of customers who have time commitments and are really trying to get something out quickly, and so EFS is a great way for them to just build on what they already know and reuse their existing applications. Yep.
A question. When will EFS bring to Japan region?
So unfortunately, I can't share roadmap details in this venue. Region availability is something that we're continuously working on, expanding EFS to more regions, but I can't share a date or anything like that at the moment.
So you mentioned that one of the benefits of EFS for you is that it's kind of unlimited scale, right? Isn't it also a concern? Because you really can't limit the consumption, and if you have some runaway process that just generates data, it will just get out of your wallet.
Absolutely. You valid point. This is why you actually have a monitoring. So one of the things that actually I had a pop-up screen there, we monitoring our I/O, we monitoring our usage also. And basically, if you look at the graph, you'll see, like if you just like that, like fluctuating just a little bit, that's one thing. But you're absolutely right. If you will see higher climb, we have something to talk about. We need to look what's going on, where's the problem coming from, and so forth. We have homegrown scripts where you actually, I guess, in the small details, we have pictures that actually full HD, but based on the user agent, we can actually resize them to make sure it fit certain type of mobile devices and so forth. So every certain amount of time, we actually run in a script and we purging the images that actually are old, resized, that not used, and whatever. So we definitely have a cleanup job, homegrown cleanup jobs that actually go in and purging that stuff out.
And another question, how do you back up this data? You do
Well,
backup?
we don't. And the reason behind, because as you understand, we have a redundant data centers. We have a custom channel, VPN channel. Basically, we are replicating between two regions. So for our perspective, God forbid, if one of the regions are down, we have a full set of backups in the second region. And to lose both at the same time, I don't think it's going to happen. So basically, good point, but we do have a live solution, live backup into two data centers.
By the way, congratulations for your journey to the cloud. We are doing exactly same. I think we might be in the same space. US, UK, 2 data center and 20 terabytes of shared storage. Planning to use EFS. However, I want to know what are the kind of IOPS are you getting in your peak time? If you're, I guess your content, you have content there, so you must be running indexes and doing the delta updates on indexes. So what are the kind of IOPS you're getting from EFS implementation?
Well, quite frankly, we never seen any issue with the IOPS with the EFS. So basically, you know, it fluctuates based on the requests and amount of requests is going and everything. But we never actually seen, I think, some spikes were up to 60%. But again, it's all irrelevant. This is what we can see. What those guys can see, I can't tell you. But basically, from our perspective, we never actually been even close to see the bottleneck. Oh my God, the EFS is bottleneck. It never happened. The local storage, yes, we definitely seen an issue. We have to do some rearrangement for certain systems which actually have ABS volumes where we have to increase the I/O, but not with the EFS.
Okay. One follow-up question. Do you know if you have like a lot of sequential reads or random reads in your file system?
Well, I can't tell you that, but we definitely have the reads are happening. I can't even say. Yeah, we do definitely have multiple reads from the same file systems and in different levels.
That's
so it shouldn't be a problem.
Thank you very much.
Not a problem. Anything else, guys?
Any other questions? All right, well, I'd like to thank all of you for coming here. It's been a pleasure.
Thank you, guys.
We have another question.
Is there a plan to support Windows?
Again, unfortunately, I can't share details about our roadmap, what we're planning. We do get that feedback from customers, so yep, that's something we're considering. Okay, thank you.
All right, thank you, guys.